So I'm just going to run a thermometer, a thermostat test on this. It's a little bit dated, still a good functioning triac. So we should be expecting, if we use the settings that are on the bezel, and it says for a 40mm nozzle, turning it up full heat, which is 10 on this, should give us 600 degrees. So let's just run a little bit of a test on this to see what it does under load and see what those differences are. So just fired it up, just going to give it a good 5 minutes to get it to temperature. The motor sounds like it's blowing well, generator's pulling all right, so let's give it 5 minutes. So we can see here the heat gun's been turned on, and we've actually brought the thermostat right up to the full capacity. So this is kind of the extreme test. So we're going to let it blow now. It has been running, and here's our thermometer that's just recording. So we can see we've got 220 in there. There is a lot of science that goes around how the volume is, or the air output, the temperature is calculated. But what we noticed during this test that, just keeping the thermostat right close in the maximum point, we were getting about, there we go, 294. It was kind of peaking 260. So that was a kind of constant. But really, when you read the settings, it should have been nearer to the 600 mark. So that wasn't achieved in this instance. So we repeated the test on a kind of more upgraded machine. This is one of the newer models of the triacs, and again we put it to full capacity. So we were getting, here we can see 519. So that was when it was turned up to 9 full on the thermostat. So even there was a slight discrepancy. It wasn't reaching the 600 that you would expect, but this machine has been used, this element hasn't been changed for about over a year, and it gets used quite frequently. So what I'm doing in this instance now is turning the thermostat down to a setting that we would normally use for heat fusing, kind of 0.5mm thick membrane, so around about the 6-7 mark on the thermostat. So hopefully this would correspond to about 400 degrees. So we can see there's quite a significant drop already occurring there. Oh, it's crept up slightly there. So just monitoring that to see if we've got fluctuation in the thermostat setting, which is always a good sign. So there's still life in this thermostat, but it would be coming to the end of its life. So just be mindful of that, and just don't assume that thermostats or the elements within the heat guns last forever. They take a lot of abuse. They run a lot of time. So, but here we go. This is kind of leveling out 420 there. As you can see, we mirroring the test that we did with the first one. So it's holding pretty close. I'd be quite comfortable to work with that on the membrane. So we were just zooming in there on site of the settings for the different thermostat numbers, so how they correspond, and we were running there at 6 to 7, giving us the centigrade reading on the side. So again, that's repeated in the box of the kit. Like I always look for with learners doing their MVQ work, how they start the machine up, likewise how they cool it down. So turning it down first, cooling it for 5 minutes before you actually flick the switch off. So the one thing we don't want to end up in the realms of is having to replace these. These are the elements. So if you do start seeing wear and tear in your heat output, the chances are the element's on its way out. Make sure you get the right element. So this one, 120 volt, 1600 watts. So this is used on our 110 equipment. They do a 240 version as well, or a 220. So indications that the element's starting to fail. You won't get the heat output that we saw on that first example there. So hopefully that's helped you. And again, dip into all the paperwork that comes with your tools as well. So hope you enjoyed that, and catch you all again soon.